Hello my friends, and welcome to the practical activity of this new part 4, clustering, where we're going to build two clustering models, k-means and hierarchical clustering. And of course, we're going to start with k-means, which is actually the most popular model in clustering. And indeed, we will see together that it provides fantastic results. So you just saw the intuition lectures with Kirill, and now we're going to put that theory into practice by building this k-means clustering model in both Python and R. And now we should all be on the same page, and therefore we're going to go to this folder here, part 4, clustering, and then we'll attack k-means clustering. And we're going to start with Python, of course, and this is your folder containing two files. First, the k-means clustering implementation in the IPYNB format, which therefore you can open with either Google Collaboratory or Jupyter Notebook. And then you have molcustomers.csv, which is the CSV file, the data set with which we will work in this section to build our k-means clustering model. All right, so first step, as usual, I will explain what this dataset is about, which will allow me to explain the purpose of this mission, the why we want to build the k-means algorithm and what for, and then we'll start, of course, our implementation from scratch, step by step, and you'll take action with me to build the k-means algorithm. All right? So what is this dataset about? Well, as you can see by the title of this dataset, mol customers, well, it's actually a dataset made by a mol, the strategic team, let's say, of a mol, that collected some data about their customers. So here, it's important to see it this way. Each row corresponds to a customer of the mol, and for each of these customers of the mol, well, the data analyst of this team gathered the following information. First, the customer ID, then the genre, male or female, then the age, the annual income, and let's expand this. Well, I can't do it here, but that last variable is the spending score, and it can take values between 1 and 100. So all these features are pretty clear. Let me explain what this one means. The spending score is a metric made by the mol to measure, how much each customer spends. And so they made this metric, which takes values from 1 to 100. That's the scale of the metric, such that, well, the lower the score, the less the customer spends, and the higher the score, the more the customer spends, in a certain period of time, let's say in the past year, okay? So, for example, this customer actually spends a lot in this mall, because he has a score of 81. However, this customer spends very few in the mall because she has a score of 6, all right? So that's just a metric measuring the spending of each customer. And so now, what is the purpose of this mission? What did this strategic team or analytics team want to do? Well, as you might guess, since right now we're doing clustering, this team wants to very simply understand its customers. They want to identify some patterns within its customers, within its base of customers. And that's the key thing to understand here, when doing clustering. This time, as opposed to, previously with regression and classification, where we were actually knowing what to predict, well, this time we actually have no idea what to predict. But even though we don't know what specifically to predict, we still know that we want to identify some patterns. And that's the why of this mission, the purpose of this mission. Okay, so it's good, we understand the why, and now let's understand the how. How are we going to identify such patterns? Well, we will do this with k-means, of course, and more specifically, what we will do is we will create a dependent variable, right? We will create a dependent variable which will take a finite number of values, let's say 4 or 5 values, and actually each of the values will be a class of this dependent variable we're going to create. And that's exactly what clustering means, technically in the details. If you want to be broad on how to explain clustering, you would say that we are identifying some patterns in the data. But if you want to clearly explain how to identify these patterns in the data, well, you would say that we are building a dependent variable, we are creating it in such a way that each of the values of this future dependent variable we are creating are actually the classes of this dependent variable. All right, so this will become much more clear once, we build our k-means algorithm and we get that dependent variable we're creating. But please remember this, we are creating a dependent variable. So now we're gonna close this and we're gonna start our implementation. So feel free to open this k-means clustering file with either Google Collaboratory or Jupyter Notebook. Now I am opening it with Google Collaboratory and it is now loading it. And there you go, that's the notebook for k-means clustering containing the whole k-means implementation. And now, as usual, this notebook is in read-only mode so that all of you can access the original implementation. But since this is an action-based course where I want all of you to learn by doing, by taking action, well, we're going to re-implement it from scratch. And to do this, we're going to create a copy by clicking Save a Copy in Drive. And as you can see, this creates a copy on which you will be able to do some modifications and mostly re-implement this k-means model. All right, so now I hope we're all on the same page, ready to re-implement this. And to do this, as usual, we're going to delete each of these code cells, but not the text cells, so that we can keep that well-highlighted structure. So let's remove all the code cells only. And in a second, we'll have the clear structure of this k-means implementation, which is in actually 5 parts. Let's take it from here. First, we will import the libraries. That's the classic first step of the data preprocessing phase. Then we'll import the dataset, of course, inevitable. Then we will use the elbow method to find the optimal number of clusters so that we don't have to build the k-means model several times. Then, knowing this optimal number of clusters well, we will train the k-means model on the dataset with that optimal number of clusters. And finally, we will visualize the clusters. All right? So, perfect. That was the introductory tutorial where we explain and set up everything. And now in the next tutorial, we will start with the very first step, which is the data preprocessing phase. And as you can see, I actually prepared our data preprocessing template because even for clustering, well, the data preprocessing phase will be almost the same. As you can see, we are importing the libraries, importing the dataset, but then we won't have to, of course, split the dataset into the training set and test set, because indeed, getting a training set and a test set implies having a dependent variable containing the real results. And at this point, we don't have a dependent variable. We're just trying to identify one and to create one. All right? So no splitting the datasets into the training set and test set. And therefore, what I would like you to do now, before we do it together in the next tutorial, is to implement yourself the data preprocessing phase with only these 2 first code cells. You will get a solution, and then of course we will implement the solution together. So I'll see you in the next tutorial to start this implementation, and until then, enjoy machine learning.